This instructional video is for textbook pages 128 through 130. Example number 1, we're given our table for Maya's roof building. We would find our pattern in our table, 9, 18, 27, 45. Our values are going by plus 9 up until you get to the end where 27 is plus 18 to jump to the 45. Going across the bottom, again, finding our pattern, 12 plus 12 is 24, 24 plus 12 is 36, but to get from 60 and 36, we would add 24. We set up our fraction y over x. Our y value is the vertical distance, so that would be the 9. The x value is the horizontal distance, which is the 12. 9 divided by 12 gives us 0.75. You could also use the secondary answers, which changed. The 18 value was on top and the 24 value on the bottom. 18 divided by 24 also gives you an answer of 0.75, which is our rate of change for this table. When dealing with a graph, we're looking at the points that can be read clearly, and we're making our pattern going sideways and up, setting up the fraction as y over x, rise over run. So our fraction would be the amount of values going up, such as 9, and then our sideways value 12, which 9 divided by 12 is 75. You can also use the secondary triangle, which is much larger. 36 is going sideways, and 27 is going up. So our rise number 27 divided by our run number 36 also gives you a value of 0.75. So even though the triangles are different sizes, we have a small triangle and we have a large triangle, they will match in terms of their simplified slope answers. For our triad example, we have our value 260 and 390. So going across, day 2 to day 3 is 1 day. Going from 60 miles to 90 miles is a value of 30 miles. So we set up our fraction, rise over run. 30 miles divided by 1 day is a value of 30 miles per day. The second example is another way to solve a graph when you are given either graphs that are unreadable or graphs that are points that are difficult to find. So for example, in this graph, we have the points 5 and negative 400, and we also have the point 10 and negative 800. We can take the points and set them up in a modified table and just list them in order, 5 with the negative 400, 10 with the negative 800, and then find your patterns. 5 to 10 is a value of plus 5. 400 to 800 is a negative 400 value. And we set up our fraction y over x. Negative 400 divided by the positive 5 to give us a final answer of negative 80. Negative 80 is our rate of change for this graph. For our next example, number 3, we're using the points that are given on the graph. Now notice one of them is difficult to read, but it is listed out to the side for you. We have the value 2 with 110 and 4 with 220. Now, this method is to be used if a graph is difficult to read or you're not given a graph at all. You would take your values, 2 and 110 for the first point, 4 and 220 for the second point, and you would plug them into a modified table and then find your patterns. 2 plus 2 is 4. 110 plus 110 is 220. We set up our fraction y over x. 110 divided by the 2 gives us a final answer of 55. Example, we're going to use the points that are given on the graph. We have the point 50 and 70. We also have the point 25 and 35. We're going to set it up in our modified table. Our first point, 50 and 70. Our second point, 25 and 35. Finding our pattern, 50 to 25 is a pattern of plus 25. Going from 70 to 35 is going down 35. We set up our pattern as our fraction y over x, so that would be 35 over 25. 35 divided by 25 gives us an answer of 1.4. So our constant of proportionality for this problem is 1.4. It is 1.4 red drops per blue drop. Question number 1, what is slope? Slope is the relationship between the x and y values. Slope is also called unit rate. It's also called rate of change. It's also called constant of proportionality. It can be set up as a fraction y over x or rise over run if on a graph. 2. How is the slope rated to a unit rate? Slope and unit rate is the amount per one of information given. So it's always listed in miles per hour, dollars per day, or any other relationship shown. It's the amount for one. A unit rate is worth 1. Why is the slope between any 2 points on a straight line always the same? So this is referencing the line where the triangles would be different sizes. And why is it the same value? And so while the pattern may change, it will always simplify into the same value. Here we have what is the slope of the line. So we have the point down here at 0. We have the point here at 3, 1, 6 and 2, 9 and 3. So you can use either method. We can do our rise over run. We rose $3 over 1 grape. You could also use your point values and count. You can skip your points and still get the same answer. So I can rise $6 and I can go 2 grapes. So when we set up that fraction, y over x, 3 divided by 1 is 3. My slope is $3 per pound of grape. For this one, we're going to use the points that are given on the graph. Yes, we could connect them with a triangle and find our rise and run values. But if the points are given, it could be easier to just set up the points in the table. So we have our first point, 6 and 10. We have our second point, 3 and 5. We would find our pattern, which would be 3 and 5. Our fraction is y over x, 5 divided by 3. 5 divided by 3 is going to give you a repeating decimal, 1.6 repeating. If you set it as a fraction, you end up with the fraction 5/3. 5 over 3 is our constant of proportionality.